ended the last video by talking about variables, and so identifying the variables is absolutely critical because it changes everything that we do in statistics. If you misidentify a variable, chances are you're going to be doing the wrong type of analysis when it comes when you come to that step down the road. Okay, so just so we're all clear, a variable, you could probably define it in your own language. Formally, it is any property that characterizes an individual. Okay, any property that characterizes an individual. Okay, and so again, that's, you can talk about an individual by their hair color, their height, their weight, their sex or gender, their ethnicity, etc. So and certainly some more things that we would probably be interested in health sciences, like blood pressure, um, or blood type. So all those things are variables. All the variables that we can possibly imagine are separated into two general types, and those general types have subtypes. Okay, so you can see on the screen there, I have the types as categorical and quantitative, and then subtypes thereafter. Let's focus on the types first and what those are. So categorical and quantitative. The essential question to differentiating between the two is this one. Okay, so kind of at this step, maybe at this branch, I'll pose the question, is the mathematical difference meaningful? Okay, and by this I mean, if you take two observations or two levels of the variable and literally subtract them, does that make sense? Okay, if the mathematical difference does make sense, then it's quantitative. So think about height. Okay, height in inches. Okay, you take two heights in inches, subtract them. Does that difference mean something? Yeah, it means, okay, so if you have a 72-inch tall person and a 60-inch person, it means the difference between their heights is 12 inches or a foot. Okay, versus categorical. Um, so kind of you would come here if your answer was yes, and here you would come if the answer is no. So an example of a categorical variable would be hair color. Okay, brown minus black hair. Okay, what do you get if you do the mathematical difference? If you figure it out, let me know. But that if the mathematical difference does not make sense, then, or it does not have any meaning to it, then it's a categorical variable. Okay, so you have to kind of think about what are the outcomes? Is the mathematical difference meaningful? Okay, and then in terms of subtypes, okay, the subtypes of a categorical variable, I typically define one as not the other. So or ordinal categorical variable is something where there is a defined or a natural order. Okay, natural order. Okay, so something like the alphabet. Okay, A, B, C, D. That's an example of an ordinal categorical variable. Okay, you could also say something like the Likert scale. And if you're not familiar with what this is, that's that scale that you see on every survey. That's like agree or strongly agree, agree, neutral, disagree, strongly disagree. It's a ranking of preference or likeness. Okay, and then so those are all ordinal variables. Nominal categorical variables is everything else. Okay, so this would be something like eye color. Okay, um, sex. Okay, so eye color, blue, hazel, green, etc. Sex, male, female, etc. So just be aware of those that nominal variables. If there is no natural order to them, there it's probably a nominal categorical variable. Okay. Now quantitative, I'm just going to say the textbook stops at quantitative. It does not include the subtypes. I like thinking about the subtypes just because it actually does help when you're visualizing it a little bit. So discrete is something that you can count. Okay, count. So it has like a natural progression of 1, 2, 3, 4, 5. Okay, and continuous would be anything that exists as a range of values on an interval. Okay, so this is one where you could get anything, say, between 1 and 2. So think of like rainfall. Okay, rainfall is a great example. Okay, do you ever exactly get 1 inch of rain? No, well, you maybe get, well, if you're a forecaster, you might get, you might say you get 1, 2, and then you actually get, a quarter of an inch. But I mean, you could continuously count smaller and smaller increment, or continuously create continually smaller and smaller increments and get a more precise value. But so you could have any value between 0 inches of rain and a large amount of rain. Okay. Discrete would be something that you can literally count. So I'm thinking loaves of bread. I don't know why, and that's spelled wrong. I think it's that, loaves of bread. So you can sit there and count loaves of bread. This is 1 loaf, 2 loaf, 3 loaves. I'm counting whole loaves, by the way. I'm not counting halves. Okay. Or you can count number of people in a room. Okay. Those are all examples of discrete quantitative variables. But again, just to emphasize, your textbook does not classify these two subtypes. Okay. And again, just to help you think about this classification scheme, it could be helpful thinking about the levels of those different outcomes and or how it's measured. Okay, so here are some examples. I want you to pause the video in a moment and think through these on your own. I just want to clarify a couple. Weather condition, I'm talking like sunny, cloudy, rainy, etc. Amount of rainfall, that would be, typically they say we get 1 to 2 inches. And I think and then the Likert scale we already talked about. So surprise, surprise, you already have this as a categorical ordinal variable. Okay. The rest, I want you to pause the video, try them out, and resume when you're ready to see the answers. And here are the answers. So weather condition is categorical nominal just because, again, A, the mathematical difference does not make sense, and nominal because there isn't any natural order, right? We don't automatically default to saying sunny before cloudy or anything like that. Amount of rainfall, quantitative, mathematical difference makes sense. Continuous, it could be any amount between 0 and a large number. Okay, we went through that example earlier as well. Okay, number of hairs on your first knuckle, quantitative, mathematical difference makes sense, and then discrete because you can sit there and count them if you really wanted to. Credit card number. This is the one that I expect many of you maybe got incorrect. Only because if you take the mathematical difference between two credit card numbers, does that make sense? So for example, my mom, my brother and I all have a credit card, like a family credit card. We don't ever use it, but we have it in case of emergencies. And if we take the difference in our card numbers, they aren't 1, 2, 3. They're completely random numbers. Okay, so the mathematical difference isn't meaningful, and there's no particular order to credit card numbers. Quantitative continuous for a length of a wooden pencil, because again, depending on how much you sharpen, you could have, a pencil length of 0 to something, and relatively short, so a few inches. Okay, and Likert scale we said was categorical ordinal. Okay, so just for practice, I encourage you, make up a list of variables and try and identify them. Bring them to class or bring them to Just Ask, and I'm happy to go through those with you.